Hello children, welcome to Maverick Masters Academy. In this class we shall learn about types of sets and how they are defined. Types of sets and how they are defined. First one is empty set or null set or void set. Empty set or null set or void set. Empty, the name itself suggests that the set is empty. That means there is no element in the set. If I say all even prime numbers except 2, all even prime numbers except 2, except 2, all other even numbers are divided by 2, but prime numbers are the numbers which are not divisible by any other number other than itself and 1. That means the number which has only two factors, 1 and itself, are prime numbers. If you go for other prime numbers, those are 4, 6, 8, 10, 12. These all have 2 as a factor. Then they are not considered as prime numbers. Other than 2, we can't say any even prime number. So we mention that as simply flower braces without any element or Greek letter phi. This is null set or empty set. If a set doesn't have any element, then that set is known as empty set. For example, all even prime numbers except 2. Next type of set is singleton set. Singleton. Single means one. The set which has only one element. The set which has only one element is known as singleton set. First letter of English alphabet, you can write A. Even prime number 2. So these type of sets are known as singleton sets. The set which contains only one element is known as singleton set. Next we shall go for finite set. Finite set. The set which contains countable number of elements. That means we can count the number of elements in that particular set. The set which contains countable number of elements, then that type of set is known as finite set. Natural numbers up to 100. Natural numbers up to 100. 1, 2, 3, so on 100. In this set we have 100 elements. We can count that. Or else even natural numbers up to 100. That is 2, 4, 6, 8, so on 100. There will be 50 elements in this set. That means we can count the number of elements. If we can count the number of elements in a particular set, then that type of set is known as finite set. Next we have infinite set. Infinite, it is exactly opposite to finite set. In finite set we can count the number of elements. In infinite set we can't count the number of elements in that particular set. Say set A is a set of all natural numbers. A is a set of all natural numbers. Then we have to go on writing 1, 2, 3, 4, 5, 6, so on. We don't know where they end. So we can't count the number of elements in that particular set. Then that type of set is known as infinite set. First one is empty set in which there is no element, that set is known as empty set. Second set is singleton set. The set which has only one element is known as singleton set. Third set is finite set. The set which contains countable number of elements, that is finite set. Infinite set. Fourth one is infinite set. The set which contains uncountable number of elements, the set in which we can't count the number of elements, is known as infinite set. Next we shall go for universal set and subset. Universal set and subset. The set which considers all the elements, the set which, suppose if you are going for the set of real numbers, in this we have natural numbers, whole numbers, integers, rational numbers, irrational numbers, and all these forms real numbers. So this is universal set for all these numbers, because W is a set under real numbers. That means real numbers contain whole numbers, real numbers contain natural numbers, real numbers contain integers, real numbers contain rational, real numbers contain irrational. That means this set contains all these numbers. Then this is known as a universal set for all these numbers. So next we have subset. First one is universal set, second one is subset. Universal set means the set which contains all the elements which are considered or known as universal set. And subset, if you have two sets, say A and B. If you have two sets A and B, if A is said to be 2 and 3 and B is said to be 1, 2, 3, 4. A is 2, 3, B is 1, 2, 3, 4. If the elements of A are present in B, if all the elements of A are said to be present in B, because here 2 and 3 are present in B also. Apart from 2 and 3, there are other elements in B. Apart from 2 and 3, there are other elements in B. But we are considering only the elements of A. If all the elements of A are said to be present in B, then we can say A is subset to B. A is subset to B. Subset is denoted like this. Universal set is denoted mu or capital U. So A is subset to B and B is superset to A. A is subset to B and B is superset to A. If all the elements of A are in B, then A is subset to B. This is universal set and subset. Let us go for an example for subset. If A has 1, 2, 3, 4 and B has 1, 2, 3, 4, 5, 7, 9. Now all the elements of A, 1, 2, 3, 4, all the 4 elements of A are present in B. All the elements of A are present in B. So we can say A is subset to B. If A is 2, 3, 4 and B is 3, 4, 5, 6, 7, 8. Now here in A we have 2, 3, 4 and B we have 3, 4, 5, 6, 7, 8. We have elements of A, 3, 4 in B, but we don't have 2 in B. We have 2 in A, but there is no 2 in B. So we can't say A is subset to B. All the elements are needed to be present in the B if you are going to say A is subset to B. That means if you are going to say a set is a subset to another set, then all the elements of the first set should be in B. Then only you can say The first set is subset to second set. Next we shall go for how to write subsets if only one set is given. What are the subset of a set? Suppose if P is given as 5, 7, 9. P is a set with 5, 7, 9 as elements. Then what are the subsets of P? Then the elements 5, 7. This is a set. This is a set. This is a set. 5, 7, 5, 9, 7, 9. If you are writing all the possible combinations of all the elements 5, 7, 9, you can write like this. First, you are writing by taking one element into consideration. You are writing these subsets. These are 5, 7, 9. These are subsets to P. Next, you are taking two elements into consideration, 5 and 7, 5 and 9. As you have considered already 5 and 7, you can't consider 7 and 5. That is basic rule of writing a roster form. You can write the elements in any order. So already we have written 5 and 7. So we need not write 7 and 5 again. These both sets are one and the same. So I am not going for 7, 5 again. So I am considering the combination of 7 and 9. 5, 7, 5, 9 and 7, 9. With 9 we have already written with 9, 5 and 9, 7. Sorry, 5, 9 and 7, 9. So we need not write again 9, 5 and 9, 7 because these both are same as these both. These both are same as these both, and I am writing empty set and the total set. So whenever you are writing a subset for the given set, then you have to take one element into consideration first, next two elements, next three elements, like that. How many elements are there? That many elements are taken into consideration and their combinations should be considered to write the subsets of the given set. And the subsets are empty set and the set itself. Every set has empty set as subset. Every set has empty set as subset. Empty set and the set itself are considered to be subsets of that particular set. So this you need to remember. Empty set is subset to all sets. Empty set is subset to all sets, and the number of subsets we can write is 2 power m. 2 power m, where m is number of elements in the set. Here we have 3 elements, 1, 2, 3. So m is 3. Then 2 power 3, that is 2 into 2 into 2. 4 2s 8, 2 2s are 4, 4 2s are 8. So there should be 8 number of subsets. 8 number of subsets. Number of subsets is 2 power m, where m is number of elements in the set. So we have 8 here. We got 1, 2, 3, 4, 5, 6, 7 and 8 subsets for this set. So 2 power m is number of subsets and m is number of elements in the set. And if you have to write the subsets apart from empty set, then there will be 2 power m minus 1 number of subsets, that is 7. 1, 2, 3, 4, 5, 6, 7. We need not consider empty set for this formula. 2 power m minus 1. So this is universal set and subset. If you are writing the set of subsets, that means you are considering the subsets and you are making them as a set. Here this is set of subsets of P. Set of subsets of P. Then this is known as power set of P. Power set of P. If you are writing the set of all the subsets of a set, then that set is power set of the given set. That means you are considering all the subsets as elements of the set. Next we shall go for equal sets and equivalent sets. To understand equal sets and equivalent sets, we need to know one more term in the sets, that is cardinality of a set or cardinal number of a set. Cardinality of a set or cardinal number of a set. What do you mean by cardinality of a set or cardinality of a set? Suppose if you have A is equals to 3, 4, 5, 6, then the number of elements in this set is nothing but cardinality of that set. Here that is 4. Number of elements in this set is 4. Then we have to denote that as n of A, that is number of elements in A is 4. This is cardinal number of A or cardinality of set A. Cardinality of set A. Now, if you go for B is equals to 9, 10, 14, 16, 18, then there are 5 elements in this set. So, cardinality of the set is 5 or cardinal number of the set B is 5. So, in order to understand equal and equivalent sets, we need to know this. What do you mean by equivalent set? If the number of elements in set, two sets are equal, or else cardinality of two sets is equal. That means n of A is equals to n of B, irrespective of the elements present, irrespective of the elements present, then that those sets are known as equivalent sets. That means if you have PQRS in set A and in set B you have 1, 2, 3, 4. These elements are nowhere related to these elements, but number of elements in A is 4. Number of elements in B is 4. If the number of elements in A and number of elements in B are same or equal, then we can say these two sets are equivalent sets. And in the second case, that is equal sets, when do we say two sets as equal sets? Then if every element of A is present in B and n of A is equals to n of B, that means here 1 is present in A and 1 is present in B. 2 is present in A, 2 is present in B. 3 is present in A and 3 is present in B. Then you can say A is equals to B. That means A and B are equal sets. That means whenever you have every element of a first set in second set, every element of a set in the second set, then those two sets are said to be equal sets and their cardinality must be equal. Their cardinality must be equal. Then only you can say these two sets are equal. If you have one more element in B, that is 4, you have every element of A in B, but n of A is not equal to n of B, then you can't say these both as equal sets. Equivalent sets means the cardinality should be equal. N of A is equals to n of B or n of P is equals to n of Q, like that. In equal sets, every element of the first set should present in the second set and their cardinality should also be equal. Then you can say those sets are equal sets. Next we shall go for joint sets and disjoint sets. joint sets and disjoint sets. If you consider two sets, and if there is at least one common element in both, that is if two sets have at least one common element, then those sets are said to be joint sets. Here we have 1 and A as common. Even if you don't have A also, you have 1 in common. So if there is at least one element in common in both the sets, then those sets are known as joint sets. If there is no element present in common, that means if you have ABC here and 1, 2, 3 there, these both sets are distinct sets. That means there is no common element in both. Present in both. Then these sets are known as disjoint sets. Joint sets means there should be at least one common element in both the sets, and disjoint sets means there should be no common element in both the sets. Then that type of sets are known as disjoint sets. So these are all types of sets. In the next class we shall see representation of sets in diagrams, that is Venn diagrams. Bye bye.